This is a beautiful rainbow. You all must have seen a rainbow in rainy season, right? Have you ever wondered how the colors of a rainbow end up in seemingly perfect bands? And how does a rainbow actually form? This and other similar questions in our day-to-day life can be answered by a phenomena called refraction of light. Rainbow is an example of refraction of different colors of sunlight. We will learn about refraction of light in this video. This video will cover following points. What is refraction of light? Why does light bend when it travels from one medium to other? So, I will start with what is refraction of light. Have you ever noticed a filled glass of water? The bottom of the glass appears to be raised, right? I wonder how that must be happening. Here is a transparent glass container filled half with water. Can you tell now how the glass rod will be visualized? If glass rod is placed halfway in a glass of water, the glass rod is appearing bent. Now if I fill the same glass with oil and then observe the glass rod, wow, the glass rod has disappeared. And can you tell what will happen if we put soap solution instead of oil in the glass? Try it yourself. Now, how do we explain this? The transmission of light across a boundary between two media is accompanied by a change in the speed. This phenomena is referred to as refraction of light. This explains why does water in swimming pool appear less deep than its actual depth. As light rays enter from air to water medium, their speed changes. This causes the light ray to bend inward. This is to explain why the direction changes when the speed changes. But this is still not clear that how does this refraction happen? What exactly happens when light changes its speed of travel while traveling from one medium to another? We will learn about it in the next activity. Why does light bend when it travels from one medium to another? Here is a glass bottle. I'll place a model of an aquatic plant inside the bottle. Now observe carefully what happens when we place the bottle inside the water without dipping it fully. I can see that the bottle is visible, but the aquatic plant is not visible. What's the magic happening? Can you tell what will happen if I fill bottle with water and then place an aquatic plant inside the bottle? Surprisingly, the aquatic plant is visible now. How this is happening? This can be explained with the principle of refraction of light. Light bends its path wherever it travels from one medium to another. Light is refracted at different angles depending on the transparent material it passes through. The combination of angles through which the light bends make the aquatic plant disappear and reappear when the bottle is filled with water. Soldiers march with the same speed. When soldiers enter from terrain to mud region, the speed of the first soldier slows down. And as the first soldier slows down, next all soldiers slows down. This changes the direction of travel of the soldiers due to difference in time. Similar way, light rays traveling from rarer to denser medium slows down and their direction changes at an angle. This analogy explains how light bends while traveling from one medium to another medium. Here we understood how light changes its path while traveling from rarer to denser medium. Join with me to learn bending of light using more activities. I will take a glass filled half with water. I'll add few drops of Dettol to it for visualizing light rays properly. I'll bring a lighted incense stick near the mouth of the bottle and close the mouth for some time. Now I will point laser light from rarer medium to denser, that is air to water. What will happen? The light bends inward towards the normal, making an angle of refracted ray smaller than the incident angle. When we see a fish angularly under water, then light gets refracted by water. As a result, we see the fish, but that is not exactly on that position where we saw it. That's why the job of a fish catcher is little tricky. The diamond has a value of $1 million, while a cut piece of glass of same size is worth of a few dollars. How can a jeweler tell the difference between diamond and a cut glass? We present here an interesting experiment which can explain this. I will place a paper cutout of an arrow behind water-filled glass. What do you observe? The arrow looks flipped behind the water-filled glass. What is happening here? This is happening because of collective refractive indices of air, water and glass. Normally, light beam travels slowly in denser media. As a result, light deflects towards the medium of higher density, as explained in marching soldiers activity. The refractive index is a dimensionless parameter that helps us in our estimation or determination of the degree of bending of a ray of light entering from one medium to another. This answers how jeweler differentiates between diamond and cut piece of glass. Many things from our day-to-day life can be well explained with the phenomena of refraction of light. So should I tell you why does sky appears blue in color? Here wavelengths come into the picture. We won't be going into much details of it as it is a higher class topic, though we will try to understand why does sky appear blue in color. Blue light has shorter wavelength than red light. Shorter wavelength light refracts more as compared to longer wavelength light. For the same reason, the sun looks red at sunset as the viewer is located at far distance. The blue sky is immediately visible to the viewer below the sun. Other day-to-day life examples of refraction of light are contact lens, object dislocation in water, prism, the lens on your smartphone, camera, etc. Try to find out other examples of refraction of light in your surroundings. Thank you.